Unit 4, Section 11.6 Worked Examples. Fill in the blank. If the number of outcomes in the intersection of E1 and E2 equals 3, and the number of outcomes in event E1 equals 15, then the probability of event E2 given event E1 is equal to what? We are working with a conditional probability, and the formula for conditional probability is shown below. We can use the values provided in the problem to find the probability of event E2 given event E1. And I've gone ahead and put those in there, and they told us that the number of outcomes in event E1 and E2 was 3, and the number of outcomes in event E1 was 15. 3 divided by 15, we can simplify the fraction to 1 over 5. Consider the figures to the right. Assume that one number from 1 to 7 is equally likely to be selected at random. Each number corresponds to one of the 7 figures. Determine the probability of selecting a circle or a square given that a number less than 4 is selected. Let the event E1 be the event that a number less than 4 is selected. Let's find the number of outcomes in event E1. How many numbers shown are less than 4? And we see that there are 3. So that is 3. And then we're going to let the event E2 be the event that a circle or a square is selected. And now we want to find the number of outcomes in E1 and E2. How many numbers are less than 4 and circle or square? So less than 4 are the outcomes right here. And we see that only one of those is a square. There are no circles in there. So the conditional probability of event E2 given E1 is going to be 1 over 3. 2 dice are rolled one after another. Construct a sample space and determine the probability that the sum of the dots on the dice total a number greater than 6 if the second die is a 5. Here is the sample space. See the deck of cards and dice handout in the Unit 4 Section Notes module in My Courses. Let red be the first die and blue be the second die. Let the event E1 be the event that the second die is a 5. And that's going to limit us to the outcomes right here. And so how many do we see in that column? We see 6. And then let event E2 be the event that the sum of the faces is a number greater than 6. And now we want to find the number in E1 and E2. And how many of the outcomes in that column have a sum that is greater than 6? And we notice all of these right here, and that's actually 5 outcomes. So the conditional probability is going to be 5 over 6. A quality control inspector is checking a sample of light bulbs for defects. The table summarizes the results. If one of the light bulbs is selected at random, find the probability that the light bulb is good. Now this is an unconditional probability. This is what we were working with earlier in this unit. And so we want to just find the probability of a good light bulb, and we need the answer as a simplified fraction. So I notice in my table the total number of light bulbs represented is 250, and out of those, how many are good? And that's going to be 218. And I want to simplify my fraction, and I notice numerator and denominator are both even numbers, so they both are divisible by 2. So I can go ahead and divide each of those by 2. So 218 divided by 2 is going to give me 109. And likewise, when I divide 250 by 2, I get 125. And that is the simplified fraction. Now let's find the probability of getting a good light bulb given that we know that it was a 100 wattage light bulb. Let the event E1 be the event that the bulb is 100 wattage. And let's find the number of outcomes in E1. How many bulbs are 100 wattage? And if we look on the table there, we see that 88 of the bulbs in the table are 100 watt. And then let event E2 be that the bulb is good. So let's find the number that are number of outcomes in E1 and E2. How many bulbs are 100 wattage and good? And if we look in the table, we see that that's going to be 77. So the conditional probability is going to be 77 over 88. Each of those is divisible by 11, so my simplified fraction is 7 over 8.